we researched the burning of gas. That is when you have octane and oxygen and you heat it up and it will release water and carbon dioxide and energy.
In our everyday lives, we have all driven or have been driven in a vehicle. When a motorized vehicle is driven, it burns gas. This is a chemical reaction where octane and oxygen, when heated, react together to form water, carbon dioxide, and energy. The burning of gas is relevant to today's society because everyone takes use of some sort of transportation in their everyday lifestyle.
Now we're going to show some visualizations of the effect that heat has on gas. So, burning of gas. So here you can see the guy just throwing gasoline on a fire. Here you can see he already placed the gasoline on the floor, and when he dropped the flame onto it, it combusted.
Please never try this.
Yeah.
No.
I don't know, last week.
And then
That's someone-
this is an iPhone covered in gasoline. They just lit it on fire. This is when you don't kind of like pay attention to where you placed your gasoline. It just kind of explodes everywhere.
This specific reaction is done on a basin of water because gas floats and therefore the water does not extinguish the fire. I mean, it's kind of common sense, but you know. Oh, sorry. So this specific reaction of gas was done on a small basin of water, and the water does not extinguish the flame because the gasoline floats on top of the water. Should be kind of common sense, though. I suppose.
And this reaction was done on styrofoam specifically. Just can't grab the table, but yeah.
Oh, so well, we can go back to the reaction. All right, cool. Thank you. So this chemical reaction is a little simpler than most. It's a combustion reaction that occurs when octane found in gasoline reacts with oxygen in the air to form water, carbon dioxide, and energy, often releases heat or light.
You should all know this because we all learned this, but this is known as a complete combustion reaction because when substance A is mixed with oxygen, it forms CO2 and H2O.
Despite many of these negative outcomes, some pros to this specific combustion reaction is easy transportation to where people need to go and also extremely cool fiery explosions.
And just like what Yanni said, all acts shown in the visualizations that we did show were done in a controlled environment or by idiots. You should not. You shouldn't try any of what we showed here at home because you can get seriously hurt or burned or otherwise. Anyways, all of these gifts that we showed have one thing in common, is that when gasoline combusts, it releases carbon dioxide. And CO2 is perfectly safe in smaller doses, but when excess is created in industry or automobiles, it leads to poorer air quality and even climate change.
Although CO2 is conditionally safe for the environment, it is bad for certain environments where people who live in urban societies have to consume the harmful air. Keep in mind that gasoline does not always burn like this. As you may remember, incomplete combustion of octane often results in the production of carbon monoxide and solid carbon particles in the form of soot. Not only is soot a pollutant, but carbon monoxide is incredibly toxic, even in small doses.
That's true, but it is especially hard for people who live in big cities like New York or Chicago because there are so many taxis and cars that run up and down the streets all day and they burn gas and enter carbon monoxide into the environment.
So, in conclusion, the combustion of gasoline is an important reaction in our everyday lives, and though it can be environmentally unsafe and even hazardous, measures are slowly being taken to reduce emissions from automobiles all over the world and make our Earth a better, safer, more efficient place to live.
How do you produce, cleaner fuel? How do you burn fuel cleaner so you don't have the production of carbon monoxide and
I
carbon
don't
soot?
really know off the top of my head. I guess you allow more oxygen to
be introduced to the reaction.
Yes.
If you have more oxygen particles, then you wouldn't have then you would have more so excess of oxygen, meaning you could have that CO2 instead of that CO.
You have a less likely chance of having more incomplete combustion reactions,
Yeah.
I suppose.
Paul, did you happen to have fun trying out any of these experiments?
Oh, no.
I
We-
only
we
have kerosene on
personally-
hand,
I
so
did not do that.
We personally did not burn anything.
we have scary neighbors.
Or they're safe.
Yes.
Yeah, I prefer to
You
be
know what
Yeah.
Miss
Miss Helvey.
So is this the only component in the gasoline that's used in cars? Like, is it just pure octane, or are there any other components of gas?
There are other components, but we did not research them. We just simply researched the
Don't
combustion of
quote
octane.
us, but I don't, yeah. Don't take what we say, but no, I don't think that's the only component.
Which was gonna lead to my next question, like, you know, when you fill gas, like, there's the different grades. Does that have anything to do with what you're talking about, or any relevance?
You said different what?
Grades.
Great?
Grades,
So
so
grades,
like,
high
you know,
octane,
yeah,
Oh.
yeah,
low
yeah,
octane.
cheaper, more expensive, like premium versus regular.
Well, you'd expect higher grade fuel to be more efficient and cleaner for the
It has higher octane.
It has higher octane in it.
Yeah. So yeah.